Data ferrying with swarming UAS in tactical defence networks. This work is a collaboration between Defence Science and Technology Group Australia and the Swarm-Robotics Laboratory out of Monash University, Australia. This paper presents a classification system for swarm robotics, which is based on the communication requirements which enable the swarm to achieve its goal. The application which is being looked at is data ferrying. Two algorithms are presented, one which uses a distributed pheromone-based approach to equidistantly space unmanned systems around the perimeter, while the second uses an aggregation-based approach where the swarming units meet at certain locations in order to exchange data. The algorithms are formulated mathematically, demonstrated in simulation, and then shown to work in an indoor flight environment. In a future battle space, it is quite likely that network units will not be able to communicate directly due to the fact that there may be large distances and too few communication resources, or potentially because we're up against an intelligent adversary who are able to contest and deny the RF environment. In both cases, a new technique is required in order to achieve communications. We argue for the use of using proximity with data ferries to overcome the RF contention. The stigmergic approach to data ferrying is able to equidistantly space data ferries along a cyclic route, represented here by the perimeter of a square. The nodes which we are trying to send data to appear at the vertices of that square. You will see a first UAV moving off quite quickly to the right, with the second UAV following much slower. The reason for this is that the speed of the UAVs is controlled by a pheromone value, which exists at the nodes which are trying to be serviced, that is, the vertices. As a ferry comes into contact with a node, it sets a pheromone value. This node then decays the pheromone value with a subsequent ferry setting its speed based on this residual value. The subsequent ferry will then reset the pheromone value. The aggregation-based approach to data ferrying sees nodes come together and move apart in order to exchange and then disseminate the information which has been exchanged. The attraction and repulsion between these nodes is achieved through the use of locally oriented potential fields. The attraction and repulsion itself is achieved by adding additional virtual particles into the environment which exhibit a charge. The balancing or imbalance of this charge causes the attraction and repulsion. In this manner, you'll see in the video that nodes are moving together to exchange information on the side of the perimeter of the square and then back apart to go to their original locations.